understand the current state of deep learning and what the future holds. So according to Wikipedia, we can say that deep learning is a class of machine learning algorithms that use multiple layers to progressively extract higher level features from raw input. For example, in image processing, then the lower layers may identify edges, while the higher layer may identify human meaningful items such as digits, letters, or phases. Okay, so in real life, we learn from experience. Similarly, in deep neural networks, perform each task iteratively, resulting in learning from every iteration, result in a better outcome. Okay, so why it's called deep learning? So because this neural networks works on a ton of deep layers that boost up learning of algorithm. In modern era, massive amount of data is generated in addition to more data creation. So that's why the DNN algorithm gains a stronger computing power that is available today, as well as the proliferation of artificial intelligence as a service. Okay. Then artificial intelligence, machine learning, and as well as deep learning are the three terms that are usually used as synonyms, although there are different between them. So artificial intelligence, we can take artificial intelligence first, is the overreaching discipline that covers anything related to making machines smart. Okay, so AI allows machines to learn from their experience. So the machines adjust their responses to perform human activities by processing data and recognizing patterns in them. Okay, so whether it is a robot, a refrigerator, a car, or a software application, if you are making them smart, then it is known as artificial intelligence. Okay, and then machine learning comes into picture, and it is actually a subset of artificial intelligence. So it enables machines to learn by themselves through the use of given information. So machine learning algorithms try to minimize errors and maximize the possibilities of their predictions to be true. Then machine learning systems get smarter and smarter over time without human interventions. And next comes into picture is the deep learning. So deep learning is a subsidiary of machine learning in which artificial neural networks are inspired by the human brain neurons or perceptrons that basically learns from a large amount of data. Okay, so this the overview of artificial intelligence, machine learning, and as well as deep learning. And what is actually this deep learning? Okay, so this deep learning is nothing but we can say that it's a computer software that we can say that it mimics the computer network neuron in the brain, and even we have machine uses different layers to learn from the data. And then we are having number of layers in the model, and in the deep learning, the learning first is done through the neural network and everything. Okay. And what is this neural network? So here, this picture shows you the input layer, hidden layer, and as well as the output layer. So the neural network is actually a branch of machine learning, then branch under reinforcement domain, which is actually used in the prediction of any variable from given raw data through network-like structure. Okay, so the neural network structure is most likely to be a human neural system. Okay, so hence actually here it got a nucleus and as well as at the center part, and then to receive the electrical signals, and axon for signal processing, and axon terminals for signal output, and then for another resources. Okay, neuron. Okay, so the first layer is actually what actually here we are seeing is nothing but the input layer. Okay, and the last layer is actually the output layer. Then all the layers are between are, we can say that all are hidden layers. So the word deep means we can say that the network join neurons in more than 2 layers. Okay, so each and every hidden layer is composed of neurons. So the neurons are connected to each other, and the neuron will actually process and then propagate the input signal, and it receives the layer above it. Okay, so the strength of the signal given by the neuron to the next layer depends upon the weight, bias the activation function, we can say that. Okay, so each input goes into a neuron and is multiplied by a weight. Okay, so the result of the multiplication flows to the next layer and become the input. So this process is actually repeated for every layer of each and every layer of the network. So the final layer, that is the output layer, provides an actual value for the regression task and a probability of each class for the classification task. Okay, so the neural network actually uses a mathematical algorithm to update the weight of all the neurons. Okay, so the neural network is fully trained when the value of the weights given and output shows the reality. So this comes under the neural network. Okay, so what is actually this different types of neural networks, deep neural networks? We can say that different types of neural network algorithms are available. Then we are having different networks like the perceptron, feed forward, then radial basis network, then recurrent network, the neural network, and then long and short term memory, and then gated recurrent unit, then autoencoder, and then denoising, sparse, and everything. Okay, so these are the different types of deep neural networks. So we are not going to see everything. Okay, so since our aim is for the scope and research. Okay, right. And next one is the feed forward neural networks. Okay, so what is the purpose of this feed forward neural networks? So first, actually, let's start with the basic network. That is a feed forward network. It is actually a network where the data only flows in forward direction and no backward flow is allowed. Okay, so that is that here we can say that the data is fed into the input layer and further it is carried out to the hidden layers, and the processing of the input variables in hidden layer is done according to the activation function applied to the node, and later it is actually carried forward to output layer when output will be taken according to the activation function. So some activation functions like threshold activation function, then sigmoid activation function, then tangent hyperbolic activation function, then rectifier activation function, and many more functions are there. Okay, so these comes under the feed forward neural network. Okay, and next is nothing but the recurrent neural networks. So this recurrent neural network comes into a picture when any model needs a context to be able to provide the output based on the input. So sometimes even the context is in the single most important thing for the model to predict that the most appropriate output. Okay, so in other neural networks, all the inputs are independent of each other. Okay, so that is but actually in RNN all the inputs are related to each other. And let's take an example, very simple example. So suppose, so if you are watching a movie, okay, so you keep watching the movie as at any point in time, and then you have the context because you have seen the movie until that point, then only you are able to relate everything correctly. Okay, so it means that you remember everything that you have watched. So similarly, RNN actually remembers everything. So this comes under the recurrent neural model. Okay, and then next one is the again the same example we have come across. We have seen the simple example. So in this example, if I am taking, do you want a dash? Okay, so here a sentence is taken as RNN, as RNN neuron, and here you will receive a signal. Okay, that actually point to the start of the sentence. So here we have to read each and every word. Okay, so here the network actually receives every word and it will extract the word and as an input, and it will produce as the vector of the particular thing. Okay, so this particular vector is fed back to the neuron and it will provide the memory. Okay, so till the last one. Okay, the final stage is actually so do you want the last word what actually you are receiving is a word. So the last one, the neural network will provide you the probability of for each and English word, and it may be, you can substitute any kind of thing. So higher probability, it may be a calf, or it may be a drink, or it may be a burger, or whatever may be. Okay, so that comes under the RNN. Okay, right. And next one is nothing but the convolutional neural network. Okay, so let us take this thing on another example. So suppose you have to predict the next word in a given sentence. In that case, the relation among all the previous words helps in predicting the better output. So this is the main thing of RNN, and then it will automatically you may remember, or you may have a thing. Okay, so this convolution neural network is actually a unique architecture, and it will actually extract the increasingly complex features of the data at each layer, and it will determine the output. Okay, so this is actually well suited for perceptual tasks, and even I can say that the best example for convolutional neural network is nothing but the human brain. Okay. And then this particular CNN is mostly used in unstructured data. Said because we are not supposed to take so all the data what actually we are receiving is a structured data. Okay, so here we are getting the unstructured data, and then we have to do some process. Okay, so here we are receiving a image, and then the image is actually a collection of pixels, and then even sometimes we may have a grayscale picture, or we may have some color picture, whatever may be the thing. Okay, so here we have to do the feature learning, and then we know that the input layers are there, output layers are there, hidden layers are there, and based on that thoroughly we have to learn the picture and recognize, and then we have to do the prediction. Okay, so this is what in case of the CNN. Okay, then next one is nothing but the reinforcement learning. Okay, what is this actually reinforcement learning? Is nothing but we can say that this reinforcement learning refers to the goal goal-oriented algorithms. We can say that which learn how to attain a complex objective, or how to maximize along a particular dimension, then over many steps. For example, we can maximize the points won in a game over many moves. Okay, so this particular RL algorithms can start from a blank slate, and under some right conditions, and they achieve the superhuman performance. Okay, so like a pet insecticides by scolding and treats, these algorithms are actually penalized when they make the wrong decisions, and rewarded when they make the right ones. Okay, so this is the reinforcement. Okay, and then many famous algorithms are available, like Q-learning, deep Q network, and as well as state action, reward state action, and then a deep deterministic policy gradient. Okay, so these are the things available. Okay. And next one is nothing but the machine learning process. How this actually machine learning process is done. Okay, so very simple. Certain steps are available in the machine learning process. Okay, so here we have to extract the features. Okay, so choosing the features, and we have to manipulate the data set, and as well as we have to split the data set. So train the tested data set, and then we have to train the model. That is the input to train data set into a machine learning model we have to convert, and then we have to evaluate. Okay, so if desired performance actually you are not reached, then automatically again you have to tune the model and repeat the step 3. So that is the main thing. Okay, right. And next one is nothing but the deep learning process. Okay, so in the deep learning process also we are using we have to extract the features, and then here we are going to choose the features